In this video, we're going to go through box plots. So a box plot, also called a box and whisker plot, you might have heard that before, is a different way of representing the data. What's nice about the box plot is it uses five numeric summaries from the data. They call this numeric summary the five number summary, and it is made up of the minimum, Q1, which is the first quartile, the median, Q3, the third quartile, and the maximum. Now, before we do the construction, the reason these 5 points are important is the minimum and the maximum are going to give us the range of data, which kind of tells us how spread out the data is. And then Q1, the median, and Q3 kind of help us divide the data into 25% for each mark, which will help us kind of know when the data might be a little bit lopsided. To do this, you do want to make a number line. Sometimes people do a vertical number line. We'll do a horizontal number line. And it is really important that you actually label the number line with set tick marks. And then you'll put the first and last values, the minimum and the maximum down. Those will be our endpoints. And then we'll create a box out of the quartiles. So let's go ahead and just do this by an example here. So in this problem, we have the heights of 40 students in a class. So 40 is a useful piece of information because that kind of tells us where we need to look for the median. So we already can see the minimum and the maximum. All right, so the minimum is going to be the smallest data value here. And the maximum is going to be the largest, which is 77. So the next value that's easiest to find is the median. So that's what I'm going to look for next. I'm going to go to the middle. So 40 students means we need to go 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I'm having 20 right there. And that means there's 20 pieces of data remaining. So the median is in between these two values. Since they're the same value at 66, if I were to average them, it's just going to average out to 66. Okay, now I'm going to find the Q1, which is the median for the first set of data. So I'm going to look at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here's 10. That's separating the bottom 20 in half. Okay, so the median is between these two values, 64 and 65. So if I average those, that's going to be 64.5. And I'm going to do the same for the other data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, I miscounted one. There we go, right here. Okay, so that means that the median for the upper half of the data is between the 70s. So that's going to average out to 70. Okay, so I've got my five number summary. So first thing I'm going to do is I'm going to draw a number line here. And since my lowest value is 59 and my highest value is 77, I think I'll go by fives. I think that's reasonable. So that'll be 55. I'll go lower than my lowest point. 60, 65, 70, 75, 80. Okay, so I did a little bit smaller than necessary. That's fine. Just going to go ahead and shorten my number line. All right, so I'm going to go ahead and draw this information. So 59 means that my first endpoint is just a little to the left of the 60. And my last endpoint, 77, should be kind of in the middle here between the 75 and the 80. Now I'm going to use Q1 and the median and Q3 to draw my box. So 64.5 is just shy of 65. That is supposed to be a straight line. Pretend it's straight. Okay, there we go. And then 70. Okay, that's Q3. So that's the end of my box. The ends of my box. And then the median is going to go in the middle. 66 is like right over here. Oops, I'm going to go ahead and fix the top line. Okay, so what that does, or shows me, I should say, is that the data is relatively symmetrical. However, I can kind of see that the median is shifted a little bit to the left. So it is a tiny bit skewed, um, meaning the data is majority of the data, 50% of the data is here. And then the other 50% is here, which is a little bit more spread out. Not by much, though. Okay, not by much. So I would say that the data is a little bit skewed, a little bit right skewed, but not much. It's pretty symmetrical based on the way the lines are kind of shaped. It's relatively symmetrical. All right. The note is talking about making sure you use a scaled number line. That's kind of important to make certain that you can kind of see the skew of the graph. It's also really useful to use a scaled number line when you're graphing two pieces of data and comparing them like we're going to do in this next example. So here they have given us the data for two classes, and they happened to already give us the 5-number summary for each class. That was just so nice of them. Make it a little bit easy for us. But if you were to find the 5-number summary, you kind of do what we did above. You'd put the data in order first, and then you'd find the minimum, the maximum, median, and then the median for the first half of the data, median for the second half of the data. All right. And that's how you'd kind of approach it. But because they gave us the 5-number summary, that's so nice of them again, we'll use that information to graph this. Okay, so looking at the data, the lowest data value is the minimum for the second group of data, which is 25.5. And then the highest is 99. So I feel like going by tens, I think that'd be really reasonable for this. So I'll start with 20, 30, 40, 50, 60, 70, 80, 90. Let's go ahead and add to this. Stretch it out a little bit more. 100. All right, there we go. Okay, so the first wow, 5-number summary, I'm going to go ahead and plot. I'll use two different colors just so I can see the difference. It doesn't really matter, but I'm going to. I'll use red for the first one. So 32 means I should be pretty close to the 30 for the first piece of data here. I'm going to kind of do it a little bit higher than normal because I'm going to fit two data value sets in here. I'm going to stack them one on top of the other. And then the maximum is 99. So that's over here. Q1 is 56, kind of towards the middle, a little bit to the right. Q3 is 82.5, somewhere over here. And then the median is 74.5, which is pretty much right about there. All right, I'm going to kind of raise that up. There we go. So this is for, I think they have day classes. So this will be the day classes. All right, so for the night class, I'm going to use green and I'm going to plot it just right below. So the first data value, 25.5, would be around in here. The maximum, 98, would be just a little bit to the left. The 78 is Q1. So wow, the Q1 is way over here. Okay, wow. All right, so we can kind of see that this is definitely skewed, this data. Top data is skewed too, but this one's really skewed. 89 is Q3, so that's going right here. And then the median is 81, which is actually a little bit off center too. All right, so here we go. This is the night class. And it gives me a great opportunity to kind of compare the data here. I can see they're both skewed left, meaning that there are people who scored relatively low on the exam compared to everybody else. But I can kind of tell that overall the scores in the night class were much better than the scores in the day class, simply because of where the middle 25% of the data is, right? Like their 50% from Q1 to Q3 is right here, whereas theirs is from here to here. I do see that the highest score was achieved in the first class, the 99, but followed very closely by 98, which was achieved in the second class. Okay. And it just kind of gives me an idea of what's going on in the classes. Overall, it looks like most students passed, and I can kind of tell that by kind of seeing where the 70% is relative to both the data. So since this is the 50% mark in that class, right, I can tell then that that means that most of the students in the first class passed, the majority passed, and definitely the majority in the second class passed. So overall, we can kind of tell how both classes did and compare them to each other.